ang tawag sa kanila ay si Mahangin 1 at Mahangin 2. Buong buhay nila, wala silang ibang ginawa kung hindi pag-aralan ang wind at air pressure. Kaya ayon sa kanila, kailangan pag-aralan ng 2.2 ang wind at air pressure.
Nitong umaga, nakapanayam ko ang dalawang mahangin na si Arden at si Tomas. So Arden, na mas kilala bilang Mahangin 1, napalitaan namin na close daw kayo ni air pressure at ni wind.
Yes, that's true. So, I would like to start in air pressure, okay? So we need to remember four things in air pressure. First is that air pressure is the wind around us and it acts on us all the time. Second is, it's the weight of all the air around us. Third, it's the weight of all the atmospheric pressure. And fourth, it is the force produced by the weight of the air pressure pressing down. The weather instrument that we use to measure air pressure, that is called the barometer. The barometer measures the weight of the air on the surface of the earth. So it measures high pressure and low pressure. But I'm going to concentrate on the high pressure. High pressure usually brings good weather. It happens when the bits of things in the air are closer together and the air is usually dry and cool.
So let's talk about wind and the factors affecting it.
So what is wind? Wind is caused by the uneven heating of Earth's surface by the sun. It is horizontally moving air, and it is a product of pressure gradients established between high and low pressure systems. Wind is formed during the day. The air above the land heats up faster than the air over water. The warm air over land expands and rises, and the heavier, cooler air rushes in to take its place, creating wind. At night, the winds reverse because the air cools more rapidly over land than over water. Factors affecting wind. First is the pressure gradient force. It is the force that drives the air from high pressure areas to low pressure areas. The force generated due to the differences in horizontal pressure, and it operates from high pressure area to low pressure area. The second is the Coriolis effect. Coriolis effect is a deflection of wind from Earth's rotation. Winds in the northern hemisphere get deflected to the right of their path, and those in the southern hemisphere gets deflected to their left, following the Farrell's law. Coriolis effect changes wind speed. Deflection force does not simply exist until the air is set in motion and increases with wind velocity, air mass, and an increase. And third is the frictional force. This force determines the angle at which air will flow across the isobars, as well as the speed at which it will move. Frictional force may also alter wind directions.
Okay, so ngayon naman pupunta tayo kay Tomas, aka Mahangin 2. So Tomas o Mahangin 2, ano namang masasabi mo sa circulation, sa idealized global circulation, at ang pinaka-relevant ngayon sa Pilipinas ng El Nino at ang La Nina?
First, we need to remember that wind is not a stagnant force. Wind circulates around the globe due to the rotation of the earth and also from energy of the sun. The direction of that wind also varies depending on things like latitude and also factors like proximity to the oceans. However, the direction of the wind also varies. It determines local climate, it determines weather systems, weather patterns, and also how severe weather conditions are at a particular place. There are highs and lows, which is called high pressure and low pressure area. In an anticyclone or a high pressure area, the winds tend to be light and blow in a clockwise direction. Also, air is descending, which means that warm air goes down, and also clouds also leads to light winds and settled weather conditions. However, in a depression or a low pressure area, air rises and blows anti-clockwise around the low northern hemisphere. As it rises and cools, water vapor condenses to form and perhaps precipitation, causing mild to medium rain. So about your question earlier about idealized global circulation, atmospheric circulation would be the large-scale movement of the air as well as the means through which thermal energy is distributed throughout the planet. One such model that would display this is the Hadley circulation cell. The circulation cell closest to the equator is called the Hadley cell. Winds are light at the equator because of the weak horizontal pressure located there. As warm air warm air pressure result in locally low pressure, the warm air rate rises the equator, producing clouds. Instability in this area usually causes thunderstorms and large amounts of latent heat. Latent heat is just the energy released from those storms due to the changes in water vapor and liquid droplets as the water vapor condenses into clouds. As we all know, El Nino means little boy or Christ child in Spanish. These are moments in atmospheric time where we experience significant heat more than usual. These El Nino refers to the large-scale ocean atmospheric temperature and climate interaction linked to a periodic warming in the sea surface temperatures across Central, East, and in the equatorial Pacific. Typical El Nino effects are likely developed in North America during upcoming events, also in the Philippines as well. El Nino is an important issue because it exacerbates the effects of global warming within society. It affects all of us. It affects farmers, food production, also in a wide scale of issues. In La Nina, however, it means a little girl. It's also called El Vejo, anti-El Nino, or simply a cold event. La Nina episodes are basically almost the opposite of an El Nino and are periods of below average sea surface temperatures across East Central Equatorial Pacific. Global climate La Nina impacts tends to opposite of those of the El Nino impacts. In the tropics, ocean temperatures variations in La Nina tend to be opposite of those in La Nina, meaning cold weather is experienced instead of the warm weather in El Nino.
Ma'am, okay na po.
Okay na. Salamat, Mahangin 1 at Mahangin 2. Tunay ngang mahangin kayo.
May maganda ka bang kwento o istorya na nais mong ibahagi? I-email lang kami sa dumanil.escarcha.frahinaltomas@yahoo.com. Muli mga kablok, magkita-kita tayo tuwing NATSCI dito sa Kablok Mo. Christian.